Students, this is Miss Dalton, and I'll be going over Notes 2-4, which is on systems and choosing the best method. So our objective for this video is to solve systems by choosing the best method based on how the system of equations is set up. So let's go ahead and list out our methods that we've learned so far. We have the first one, which was the graphing method. And generally, it's going to be easiest to use graphing when you have y already by itself, because you're going to have that in order to graph it. Our second method was substitution. And this one is generally best used when one of the equations has a variable by itself, and it can be the x variable or the y variable. And then our last method was by elimination. And elimination is going to be best used whenever you could easily cancel out one of the variables by adding the two equations together. So let's look at example 1. Example 1 has 4x minus 2y equals 7 and x plus 2y equals 3. So what I notice is that right off the bat, my equations are in standard form because I have my x's together, I have my y's together, and then I have an equals and constant. So that's in the form of ax plus by equals c, which is exactly what needs to happen when I use the elimination method. So let's check out elimination. Let's see if I add these two equations together, could one of my variables cancel? And hopefully you'll notice that the y's, when I add these two together, I get negative 2y plus 2y. That's going to give me 0, and they are going to cancel. So let's go ahead and do that. We're going to add these two equations together. So 4x plus 1x, because remember we assume that there's a 1 there, that's going to give me 5x. The negative 2y plus 2y cancels because it's 0, and that's equal to 7 plus 3, which is 10. So go ahead and solve for x by dividing both sides by 5, and that gives you x equal to 2. Okay, let's take that x and let's substitute it into one of the equations. Now I'm going to choose equation 2 only because it has some smaller numbers. So equation 2, you're going to take the x value of 2 and plug it in for x. So the first, so for x I'm going to put in a 2, and then it says plus 2y, and that equals 3. So let's go ahead and solve for y. So I'm going to go ahead and subtract that 2 over to the other side. 2y equals 1. Divide both sides by 2. And so y equals 1/2. So my ordered pair is 2, 1/2. Remember, your x value always goes first when you write your ordered pair. Now before I box that as my answer, I am going to check it. To check it, you just plug in this for x and this for y into both equations. So let's take equation 1. I'm going to take 4 times the 2 minus 2 times the 1/2, and that equals 7. So let's check it. So 4 times 2 is 8, then negative 2 times 1/2 is a minus 1, and that does in fact equal 7, so that does work. Let's check number 2. We have our x, which is 2, plus 2 times your y, which is 1/2, and it should equal 3 if this is correct. So let's check that. We have 2. 2 times 1/2 is 1, so plus 1, and that does equal 3. So it checks out, so this is my final answer. For example number 2, we have two equations and they both have y by itself. So anytime you have both equations where y is by itself, the easiest method is going to be the graphing method. And so you're going to need to use your graphing calculator. and graph this on your graphing calculator. You could also graph it by hand, but because these y values here, or I'm sorry, the y-intercept values are pretty large, it would be pretty difficult to graph them. So again, the best way would be on your graphing calculator, which I understand you might not have at home, but I am doing it over here on the side. You can't see it because I don't have it on the screen, but what I'm coming up with the point of intersection, it's coming up to be 15, 20. And I could go ahead and check that in my equations, check it in the top equation. So here's my check over here. My top equation, I'll plug in the 20 for the y, and that should be equal to the negative x value, which is 15, plus 35, and that checks out because negative 15 plus 35 is 20, so that checks out. And in the second equation, so this was my first, in the second equation, my y value is 20, and it's going to equal negative 16 ninths times the x value of 15 plus 140 over 3. Now, since these are since these are fractions, you might want to do those on your calculator to make sure that it checks. Once you do, you will see that it checks, and so this is your answer. Problem number 3 has a system where the top equation has x by itself, and the bottom equation has x plus 4y equals 14. So because one of my equations has a variable by itself, then I'm going to take that equation, so whatever x equals the negative 3y plus 11, I'm going to take it and I'm going to plug it in for my x value in the second equation. So I'm going to take this and plug it in right here. So let's write what that would be. So I'll have a negative 3y plus 11 in place of x, and then I have plus 4y equals 14. So let's go ahead and simplify this and solve for y. So I've got a negative 3y plus 4y, that's going to give me 1y. And then I have plus 11, and that equals 14. So if I subtract 11 from both sides, I get y equals 3. So that's half of my point of intersection. So now let's take this y equals 3 and let's plug it in to one of the top equations. It doesn't really matter which one, but I'm going to put it in this top one. So what you're going to have is x equals negative 3 times your y value that we already found, which is right here, times 3, and then plus 11. So x is going to equal negative 3 times 3 is negative 9 plus 11, and so x is going to equal 2. So my ordered pair is going to be 2, 3. This is my solution. Now go ahead and check it in the original system to make sure it works, and I'm going to leave that for you to do. Okay, for problem number 4, this system could probably be solved easiest by either substitution or elimination. Because I haven't done very many of the elimination problems, I'm going to solve it using elimination. But the first thing that I'm going to notice is that my equations do not line up. You notice that this has a 2x and a y. I need my x's to come first, which means I'm going to have to switch this x and this y. So let's do that. So now my bottom equation, when I switch my x and y plus x is the same thing as x plus y. So we're just going to rearrange that, and that's equal to negative 12. I don't have to change my sign when I move these around because they are on the same side of the equal sign. So now let's line up the top equation, 2x minus 3y, and that equals 6. Okay, I'm going to leave this one for you to do, so go ahead and solve it using elimination. Okay, Remember, to do elimination, you're going to have to get one of your variables to cancel out when you add them together. So let me have you do it, you try it, and you get your answer. And I'm going to have you put that answer on the whisk form. So don't forget to submit your whisk. Don't forget. Submit the whisk. All right, we'll see you tomorrow.